Good. So welcome, team, to our first workshop. The previous workshop we had was very much an onboarding workshop. And in this session, we're going to be discussing the new hardware that you received, the new cores you received, and some additional items. Let's have a chat about the different sensors and what you're thinking about in terms of your payloads. And then we're going to go into the timelines. So you should have all received a package with some of these new cores with the 20-pin connector. You also would have received a few of these SD card interfaces. And so what it is that, let me actually just take this one apart. So the SD card interface clicks in here into the core like that. So you can write the data straight to the SD card. And so there are a few of these so that you can begin experimenting with writing data to the SD card, because that's what you're going to be doing when we go to the International Space Station. Also in your packages would have been some, let me find mine. In the US, yours may look a little bit different, but I have here a USB-C male-to-male connector, so that what I can do is that I can actually power this kit, and also so that I can program it. So these cores that you received, they do have the bootloader on them, but unfortunately the code wasn't completely done by the time we needed to ship them. So what I have done is that I sent you all an email yesterday with a PDF on how to actually load the code onto these cores. And I've also built a module in the learning management system on how to do that. So I thought at this point, Bjarke, if I can throw a curveball at you, please. If you wouldn't mind sharing with us what our extended core is going to look like, and the configuration of the SD card interface on that extended core.
Okay, so the extended core is going to look something like this. It's going to be white instead of green, as you have them here. They're in production right now, and I expect them to, well, they're almost finished, so I expect them here in a week's time. You can see I have connected 4 random X chips here, actually 2 of the same ones. So that's how one configuration can look like. There's another, so this is a spine, there's only 4 very short spine here. This is going to be 20 centimeter tall. But for the purpose of testing, I just have a shorter version here. So another board I have here have a this prototype board on it. And if I click that into the spine, just so you can see, there's very little space here at the sides. So there's a few components that's sticking out here. And that's the reason why there's a little white strip where it says keep out, as you can see here. And that means that if you use this prototype board and plug your own components in, then just keep out of this area. If I go to the board itself, so what I want to do is I want to take one of the new cores. So you have a core like this, and you can see there is a connector on this core here, and that looks the same if I hold it like that this way here. So the bottom is sitting the same place relative to this extension here. And there's LEDs here that sits on the same place relative to it. And this mounting hole here is the same as this mounting hole here. So if I plug anything into this thing here that use this mounting hole, it's exactly the same on both of them. There is a SD card connector on this. So if I take a SD card and plug it in, so on this core here, you simply stick it in and then it clicks in when you kind of like push it in like that. Sorry, like that. And it's flush with the board here. And the reason why that's important is because when this is being lowered into the container, it can't get out. Whatever rumble there is, this is actually stuck here, okay? This SD card holder that is here is of course not on the little core you got, but instead we have this SD card, little SD card expansion slot here, where you can put in your SD card like that, and then you can then slot it into to your core. Now, like that. And of course, you can take the exact same and slot it into the extended core here. So you can see here, oops, it's upside down, and that actually doesn't matter because all the stuff is it works both on the one way and another way. So here we go. So here is the SD card. Now there's still a SD card possibility here. So these there's a slight difference. The way that you connect to the SD card on this one is the same as you connect to the SD card on this one. So they use the same pins. And what I mean by that, I'm going to show just now. Also important is that this SD card, this extension port here, can use SD card connectivity called MMC. And I'm going to just show you later on what that means. But that means you can actually write 4 times faster to the SD card than if you slot it into this one. So this here use the traditional SD card connectivity that you're used to from the old extended core. But with this port here, you can actually write to the card much, much faster than you can originally. And that can be important if you do, for example, something with an accelerometer or other sensor where you want data very, very fast. Just remember, 32 gigabytes, and you have to have it up there for a month. So I don't suggest you write very, very fast for a month. You might not have room for that. So that's the, otherwise there is no difference that you can see kind of like as a user interface. The buttons are the same and all the pins are the same. So if you program to program this thing here to a X chip, then it uses the same I2C pins as this one do. So you can simply move the code from the one to the other. If you use this for the SD card, you don't have to change anything. This one has PS RAM, so 8 megabyte of PS RAM extra. This one doesn't have the PS RAM, so if you have something where you use PS RAM, if you do some AI stuff or like camera stuff, which this one here can't do, then you need the PS RAM. And then I have a CAN bus transceiver, so you can communicate with the motherboard using CAN bus. But I want to go from here, Judy, to the programming, so I'm going to share my screen. So let's do that. And just going to move that away here. Share. So you should be able to see my screen now. Is that, do you all see a Google screen here? Okay, that's great. So The first I want to show you is that if you go to dominant4.com/CWA, then you end up on GitHub for this CWA here. And you can see that there's an old core that we used to use historically. Those who have been on a program for a while, they will recognize the old core. So that runs ESP32, the straight ESP32. And then there's a new one here from version 2 plus that runs this ESP32 S3. If you want to program it, you can connect it either with, well, the old one you could connect with your PPU. So the PPU is this fellow here, so Power Programmer USB. You can see here I say PPU version 1. That's because there's a slight update in the PPU. So this is the old one and a new one. You can always read the small letters here on the back that will tell you what version it is. But the way I look at it is that you can see there's these two new transistors here. On the new one, there's not on the old one. We haven't released that yet, so there's still this one here. And you can't actually use it to program the new core, but you can use it to power your circuits, okay? The new core, because I actually thought it was finished, but it's gonna have a little bit more functionality that I think is gonna be useful. So I'm coming back to that on a later stage. But the way you would program the new core is that you would connect it with a USB-C. So you connect it with USB-C here, and that have some major advantages. First of all, it powers the project over this, similar to what this do, but also you connect USB-C instead of maybe the old school USB-A, depending on what kind of computer you have, that might be important. The other thing that's important is you can do inline debugging of your core. So when you program this thing here, instead of you go in and put print statements everywhere to see, where your program runs, you can actually go in and debug, and you can do step by step, and you can do breakpoints, and you can see the values of the variable. So it's much easier to debug using this thing here. There's plenty of videos about it. I'm just gonna show you just now where it is in Arduino. So if you want to play around with it, you can do that. Let me go back to the screen here. So in the settings, what you have to do is you have to choose with the old core, you chose ESP32 dev module, and the new one, you choose ESP32 S3 dev module. And then you can choose the flash size. Normally it just default to 4 megabytes, so you don't have to choose it here. And you can choose 8 megabytes. There's room for 8 megabytes in this core. If you choose 4 megabytes, it's fine. If you don't change it, it will just complain if your program gets too big. I have yet to make a program that's so big, so I have to remember to make 8 megabytes. Using the USB to program it, then you can have to set the maximum speed, like an old one, to 460,800, and of course the same with the new one. And then there's an option, and I'm going to show you that in Arduino just now. There's an option that says USB CDC on boot. It's not important for the old core, but a new core you have to set it to disabled, which is the default if you use the PPU. And then of course the port is the port where you plug it into. If you connect it via USB-C, and this is the way I'm kind of like demonstrating it here, then your speed doesn't matter. It doesn't use the speed function to anything. What's the matter is that you set the USB CDC to enabled. Otherwise, you're not going to see the output from your serial prints. So when the serial prints and you set it to enabled, the serial print comes out over the USB. If it's disabled, it comes out via if you have connected to the PPU. And of course, again, you choose the port where you connect that to. And I'm going to demonstrate that just now. I'm not going to go through
Bjarke, can you
this
step
whole
back from
document.
that for a second?
Yeah.
So we have to enable USB CDC on boot in order, for instance, if we're programming or running over the Arduino IDE, if we want to see anything on the serial monitor, we have to enable USB CDC on boot.
Correct.
And can you go over again how to enable that?
I'm going to show it in Arduino just now.
Okay.
So what I'm showing here, I'm going to show in Arduino also. So I'm going to go back. I just want to show it in the document here, and then I'm going to show you in Arduino how I do it.
Sounds good.
There's just a few things here on the buttons, just so we can remember that. So this is the buttons that you had in the old version. You had the touch button on the old one, and I can't find the old one right now, so you have to believe me. And in the new one, you have two new buttons. So you have these buttons here, up here in the corner. Sorry, this little out of focus. So the one have this play button, this little play logo on the top, and the other one have this rotating. I know it's a little bit out of focus here. Has this rotating arrow, which is a reset. And okay, thanks. So I'm gonna show it on this one here that Judy brought me here instead. Okay, so there's these two buttons here, and there's these two buttons. The one that says play here, you can use that in a program by referring to GPIO 0. So this one here. The other one is a reset button. And there's a couple of notes here on how to use this button, because in the old solution, we didn't have these buttons here, and that was just for programming only. But here we're gonna change them a little up here. So I'm gonna connect this one here. And you can see here that this is blinking. So if I press, this blink because it's running some software. If I press down on the top button, and the way I do it is I take my finger and I start from the top down to the reset without letting go on the top, and then back again. So that looks like this, okay? So when I did that, the red light comes on here, and now it's in program mode. That's what I'm referring to here in the text. So when I did this thing here, it's in program mode. If I wanted out of program mode, I simply press reset. This is the button, the second one here. So I click one on this, and you can see now it goes back to run whatever program that was installed on it already. Okay. I can also install, you have two bootloader on it, and that's default installed on this one. Judy used it for some things, so therefore there's always software on it. If there's a UF2 bootloader on it, then you simply double click on the reset button in order to activate the bootloader. And that you do by clicking reset twice. And now you can see there's a red light that pulses. You should be able to see how it kind of like fade in and out. And there's a green light also, and that's to tell that it's actually connected to USB-C. If you do this thing here and it's connected via one of these, the bottom line will be turned red and say, listen, you're not connected correctly. And what happens now is that when I do that, I will have a CWE drive, as you can see here, a CWA drive for this thing here. So with this CWA drive, you are able to now program this thing here by dragging a UF2 file, a ready-made UF2 file, into this drive. If it's in this mode here, sometimes it can be difficult to program it. So if you program it like using Arduino, then you should do this little exercise first and put it into programming mode. I just have to see if I can do it properly here. Yeah, now it's in programming mode. the red light is now constant. And you noticed on my screen, I don't know if you did, but the drive went away. So I don't have that drive anymore. That is gone from my drive here. Okay, I'm going to show you two things now. First, I'm going to show you how we use this UF2 stuff here, because that's kind of like the easier. And then I'm going into Arduino and show you how you program it. So in here, I say you can install a UF2 bootloader here. And when you get the core, it's already have the UF2 bootloader. But if you program it using Arduino, then you overwrite that bootloader, and then you have to install it again. So I have this apps.maxiq Space up here, and up here you can see how you install a bootloader. So for the sake of it, I'm just going to show you how you do that. And what you do is that you go up here and click install, and then there's a port coming up here, especially because it's actually in programming mode here. So I go in there, and by the way, in the text here, I say if the connection is troublesome, put the CWA into this download mode as it is here. And you can see it says press and keep holding down the play button, press the reset button, release the play button, and this red light will continuously illuminate. Okay, so that's what I've done already here. So now I click install, and I click up here what port I want to install it into. The other port, Bluetooth here, is of course a Bluetooth connection that's not for this purpose. And I then click install, and what it does, it's connect. I can then say erase, and I can say install the Domino 4 UF2 bootloader. Now, while it's doing that, on the screen here in the background, you can see there's a couple of other apps. And these apps are actually UF2 ready apps. So we can just install them directly. I'm going to demonstrate that. So now that it's running its little program here, at a certain point, you will be able to see that now it says installation complete. And then I can actually press reset here. Now, when I press reset here, it actually goes into the UF2 bootloader mode because it's empty. So it can't run anything. So it just goes into this UF2 bootloader mode. Now, what I'm going to do is I'm going to connect the screen. And then I'm going to take one of these programs here. So I'm just closing this window. So here's underneath is a list of projects with ready-made UF2 file. You can just try the different ones here. So we have the starter kit, which you can use with the different sensor you have. The soil moisture sensor run on a separate one. Then we have a tiny ground station, and you need a lower radio for that. There's MicroPython, and there's should be a link here's a link to micropython.org, so you can see how that works, and there's a scanner and so on. So what I'm going to do, by the way, this needs to be refreshed, this thing here. That's better. So what I'm going to do here is I'm going to install the I2C scanner. And what I can do, instead of downloading to my computer and then drag and drop it to the drive, I can simply right-click on this thing here and say save link as, and then I can go straight into my CWA drive here and then say save. So now it flashes very fast because it's busy installing this thing here. And as soon as it's finished, then you can see here on the screen if something happening. I can't see to get the focus here, but right now it's actually operate as a UF2, I2C scanner. So if I put another chip in, then I should be able to see that. So here I put in another chip, and you can see there's 3 lines here, maybe out of focus. So that's how you do that. Now it's running something, but now you have the opportunity to put it back into UF2 bootloader mode. And what you do there is as it says here, somewhere it says here, double click on the reset button to put it into UF2 bootloader mode. So you do that by double clicking on the reset, and then it comes up. Sorry, it so there's a reset. Here we go. And now we get this pulsing red and the green one here. And I can now take the starter kit and I can do the same thing. I say save link as, and it goes into the CWA, and then it programs it. And then just now it should be finished. And then it comes up here with MaxIQ, so there's another program running. Okay, now I'm gonna, this is the stuff where you can load your own software onto it. So remember, now I'm gonna program it in Arduino. When I do that, this bootloader here that I can activate by double clicking on reset disappears. So I have to now install it again if I want to use the system. But let's look at Arduino. So in Arduino here, I'm going to put this down for a second. So I'm going to take an example to just show how this works. So this example, I'm going to take the blink example here. And in order to use the blink example, it uses LED that's called LED built-in. And we just want to configure it ourselves. It was not here. Here we go. So if I go here, I can see here that I have under the this LEDs here, I have in version 2, I have the red LED as IO40 here. So I'm now going back to my program here, and I'm defining this thing here, define this as 40. Okay, now it's running a program already. And it could be in UF2 bootloader mode and so on. So if I can't program it, if I have any problem programming it, I'm going to put it into download mode by clicking play, reset, play, you know, that little movement here. So let's see what happens here when I do this thing here. So first of all, I don't have any LEDs showing here. I'm going to take the screen off so it doesn't confuse anything. So there's nothing happening on it here now. Up in tools, if I want to write something out on the serial, there's nothing in this program that writes on the serial. But if I use ESP32 S3, so let's start with that. Here, I'm going to go in and say ESP32 S3. You used to set ESP32 dev module. Now you set ESP32 S3 dev module. The port, and you can see there is no port here because it's actually probably it's configured as a drive or something like that. So in order to find the port here, when you have any kind of these kind of problems, you put it into download mode. And that's play, reset, play, and then you get the red light here. And then we go back, and now you can see I have a USB port here, and it says ESP32 family device. If you connect with USB-C and you do this thing here, you should see something called ESP family device. So now we have that. This CDC on boot, because I use this thing here, even if I don't print out on serial, I just do it because I don't know, suddenly I will print out on serial and I forgot I set that. Down here with flash size, I can leave it at 4 megabyte, but 8 megabyte. You can't put it higher because there's not that amount of memory, but you can put 8 megabyte. And then finally down here, you can see there is a speed. If you use the PPU, this one here, you have to use the speed down there. There is actually a higher speed than that it can operate on, but it's not available here. So therefore, I don't suggest it. There's a lot of other options, but I'm not going to cover that because I never used them myself. Okay, so let's start with programming this thing here. So I just clicked upload this button here, and it's gonna run. Now, when it's finished programming, because I forced it into this download mode or program mode, then I have to also take it out of it. If I program it, if it puts it into the program mode itself, it will also take it out of the program mode itself. But in order for me to do that, I actually have to be able to program it the first time. And I'm going to demonstrate what I mean by that. But when it's uploading, so you can see now it's uploading the program, and now it's finished uploading the program. But this thing here is still red. So now I press reset. And now you can see the LED blinks with the frequency set in this program here, which is like once a second, it's going to blink. So now I have programmed this thing here. If I now take another example, so underneath, if you install this thing here, you can see underneath here, there's ESP32 dev module here on the screen. And all these different apps here you can use for the ESP32, almost all of them. You can't use Bluetooth serial because that's for an older version, but you can use BLE. But all these different ones you can use. If I go into ESP32, I can go into GPIO, and there's something called Blink RGB. So the Blink RGB is the other LED, this green one that was underneath. That's actually what's called a NeoPixel. So I can take this, I can go up here and say, define, if I can spell it, define, and that was 39. So that's the only thing I changed in that program. Let's see if I can just program it. So in this case here, I haven't put it into download mode because it should be able to now communicate with it easily. But if it doesn't, it could be, for example, I'm doing something on a code that's very heavy, so it can't force it into programming mode, then I can do it manually. But blinking LED is doesn't cover doing anything heavily here. So now it's busy starting the uploading process. And that's here where you normally find that things can go wrong. And here it works fine as I expected. So I haven't put it in there. And it will reset it automatically. And now I can see that it actually changes the color from red, green, and blue as set up here in the code. So this thing here does it in a loop, and then it, and that's kind of what the program do here. So now you have actually programmed it, and you can see that it been programmed twice. The second time, I didn't have to press any button. So once you get in to start programming, you can just keep programming like that. Now, I just want to go back to this bootloader here, where it says that if you want to install a UF2 file, you double-click on reset. But remember, the bootloader is gone. So when I double-click on this, nothing happens because there's no bootloader on it. So if I want to put a bootloader on this thing here, I have to reinstall it up here. So I go in and say connect, and then it will reinstall the bootloader on this thing here, and I get back to the situation where I can use the UF2 files. Judy, I think I bombarded everybody enough here, so I'm gonna start taking questions.
Great, absolutely. Bjarke, I think what I really like about this new core is I've been experimenting a lot with it. And so what I've done is that I put the starter kit code onto it, and what happens is that you can just connect all of the sensors, and it only comes up on the OLED screen if that sensor is connected. So it detects it and then it shows it. In the earlier version of the STEM kit, when we didn't have a sensor connected, there would be a big cross through that screen. But now, if it's not connected, it just doesn't show that screen. So I really recommend that everybody tries the starter kit code, because you'll see that it actually works with all of the sensors, except for the soil moisture sensor. The soil moisture sensor needs a different set of code, And that is why on that screen that Bjarke showed us, if you want to use the soil moisture sensor, then there is there's another set of code. And the reason for that is that the accelerometer and the soil moisture sensor use the same, what is it? It's the same pins or something, Bjarke. But what happens is that the core gets confused if they're both connected. So what we're doing is we're erring on the side of using the accelerometer, because that's going to be more interesting to use on the International Space Station than the soil moisture sensor. So for this particular project, I really recommend that. Bjarke, if you wouldn't mind just sharing with us the progress on writing the data to the SD card when we add the SD card to that 20-pin port.
Okay, so maybe what I should do is so what do you mean progress? How we write to the SD card, or? Okay.
Yeah, I was just wondering if you've got any tips or anything so that everyone can get going with experimenting with writing data to the SD card.
Okay, cool. So let me just do this. Okay. So I'm gonna share my screen again. Just hang on a second. Okay. Share screen. So on my screen now, you should be able to see that I have a program here. So this program here, if I go into examples, and down here you can see there's something called SD.
Sorry, where are you? Are you in Arduino IDE examples?
Yes, I'm in.
Okay.
Yeah. So sorry, up here. I know it's different windows, but on a Mac, I have my menu up here. So if I go to File and Examples, then underneath this section here, so this is the standard built-in examples. All these examples is the example that comes with the ESP32 S3. So when you go through all these examples here, down here, there's something called SD. So that's normal SD card read and write. And then there's SD MMC. There's also like this interesting program here that is called SD USB MSC. And that is that you can program your device to be a memory stick. So you can actually read the USB card, sorry, the SD card over the USB on your computer. With this with this app here. So if I take like this test program here, you can see that's exactly the one I have underneath here. The difference is that, so it should be more or less the same, is that I have been in and defining these pins. So these different pins we are using, them I have been in and configure them in here. So here that's kind of like in a comment section that talks a little bit about the pin. So how do I find out that I should use these pins? Well, that is on this data sheet here. So under that, you can see here, there says expansion port. So that's that black port where you put the SD card into. There is then a reference to what pin you use for MMC and what you use for standard SPI on the other column here. So 33, 4, 5, 6, 7, 8 is the pins that being used for the MMC here. And that's the ones I have in my program here. 30 these different pins here is configured for MMC. In the bottom of the program, you have the setup. So the setup is like that. So we go to my setup, which look like this thing here. And there, this is the standard program that's not configured. This is mine over here. That is configured. Let me just make it a little bit more visible like that. So this is the one from the example, this one, and this is the one I had done. And here it says that you can go in and tell what pin you want to use. So you have something that's where you can use one pin or 1 bit. So you can see here it says 1 bit MMC. So that's if you want to use 1 bit. But why not use 4 bit when you can? It's much faster. So this is the configuration of that. And that's what I've done over here. So in the top, I defined these 6 pins, and here I set them. And that's it. The rest is actually, I haven't done anything else. So that's how you're using that SD card. And you can use this TED program here because I think it actually comes out and in the timing circuit and show how fast it reads and writes. And you can then run one of these timing circuits to figure out how fast it is. A couple of important notices. The SD card can maximum be 32 gigabyte. And when you start using this MMC, the quality of SD card matters. So it can read, like, as you can see here, SDHC cards, SDSC cards, and then of course it have this thing here called MMC, which is like the normal cards. If you use the card for something else, you need to format it as it was formatted when you received it. And if you don't know how that was, there is an organization called SD.org. I think it's called that, something like that, yes. So I'm going to put the link to that in. And this thing here is a formatter you can download for all kind of operating system. And when you format with this thing here, it will work like the same way as when you bought the SD cards. Zoom and chat. That wasn't Zoom. Let me do this thing here, then I can find it over here. So I put that thing in. So that's how you program it for SD cards. Julie?
Bjarke, sorry, maybe it's me. You were referring to the example, and then you were referring to your code that you've done. Where do people find that? Where do they find your code that you've done?
Yeah, so I'm happy to. I mean, first of all, whatever I've done of the changes is available. So I can show you here. Did I do that? Anyhow, I'm going to show you where I did it, but there's this configuration of the pins, and I realized this is actually from the other code, from the example. But the important part is that you configure these pins, and then down here you tell that you want to use the pins as it shows in the example here. And that's the only thing.
Sorry, you're no longer sharing your screen. Sorry, you're no longer sharing your screen.
Good point. Here we go. Share. So this is the example that I loaded from the built-in example. And this one here, it starts up at the top, if you open that, and say, I want to use these pins. What you have to do is that when you kind of like want to configure these pins, is that you should go in and look at the pins as they are described here. So you can see here that meso pin is 38. Sorry, that's 0. So that's this one is 38. So that's the same. CMD is 37. So that's have to be changed. And clock is 36. And that's the same, and so on. So you change these 6 pins to this thing here. And then what it also does in the bottom, it says you want to set the pins. So what you want to do is you want to take this piece of code here and uncomment that. Okay, so I'm gonna take this away, move it here, and then do this, and that's it. Then it can actually, then you can actually run it if you set the pins. So that's actually how it is. Fairly simple to do these two things. I hope at least in the recording that's done there.
Okay, and I just want to reiterate, because one couldn't see it all that clearly, but those pins were described in the, where we have the link, domino4.com/CWA. That is where you've defined those pins on that page.
Yeah, so they are defined, they're defined, sorry, wait, just get rid of this. They're defined here. If I go to domino4.com/CWA, this screen here where it talks about these different things, if you go down to the expansion port, then you can see how the pins are configured here.
Great, perfect, thank you. Okay, great. Do we have any more questions for Bjarke before we move on to the timelines?
I have some questions.
Great.
Go for it.
So my computer just died, so I'm on my phone and I can't see much. But your example SD card code, what you were showing, is it only functions available for reading and writing, or did you incorporate some actual reads and writes into the code itself? Sorry, let me back up for a second. I also wanted to mention, we're pretty in the weeds here, so I also wanted to agree with Judy, voice my support for Judy's recommendation that beginner schools just start with the bootloader code, the provided UF2 files, and just load some of the preloaded code and get your sensors working out. But once you get past, so suggest everybody start with that. But once you get past that, then we're in the weeds of what we're talking about now. But anyway, did you try some reads and writes in your code, or does your example code include some actual reads and writes? Because we hit some challenges with that.
So I do reads and writes. So if you use, if you, for example, let me just share this in here. I know you can not really see it, but if you use, for example, this starter kit here, where you can plug in the different sensors, you can also plug in the SD cards, and it'll write to the SD cards.
Right, but we can't see that code. I mean, we can't see the actual.
No, I'm releasing the code very, very soon. It's just not in Arduino, it's in Platform IO, but it's still Arduino code, and you can cut and paste from there. So I'm releasing that code. But anyhow, I'm happy to make a piece of code that read or writes to the SD cards the way I just described it. So that's fine. I can do that, and then I can upload it somewhere.
Well, what I'm getting at is when we've been doing this with the old extended core.
Yes.
And for some reason, we found that we cannot put reads and writes in the usual loop of the sketch.
Oh,
they have to be in a sort of contrived endless while loop in the setup block of the sketch, or otherwise everything crashes. So I don't know if you've had success putting read and write function calls in the loop, or if you also have to put them in the setup block, because where this leads is it determines where you also have to put your X chip sensor reads.
Okay, so here's the thing. I think I understand what the problem is. In this example, on any of the other SD card example, whoever made this example here, we haven't put his name here, but whoever made this example made it a little bit difficult, because down in the bottom here, where, for example, it says list directory and create directory and that kind of stuff. I don't know if you can see it, Mike.
I can see. I'm zoomed in.
Okay, good. So here, when it, for example, if you want to write the file, it passes this SDMMC. Okay. And then you go into a function up here somewhere, like for example, this write file, and that comes in like this thing here. But for example, if I just want to write to the core, okay, and I delete, all the code on both sides here. Where did I get to? Here. Let me just do this thing here. Actually, let me do it this way. If I take where's write file, let me take a pen file. If I want to do this in a separate program, file, new sketch. Okay. So in this thing here, let's say I want to write something. Then instead of having this function here, I'll just do it straight into here. What you have to do is instead of this SDFS here, you just say SDMMC. Okay. Now it will write to this file. It will open the file and write to this file here. Now, if I finish this program here, what I would do is I will do the definition, this pin definition that we had before. So let me just do the setup. So that's like this part here. So this is what I will steal from here and say setup. And then I just need to define the pins like that. And I know that you not necessary to maybe follow this or copy this in here. But what I'm doing here is that I'm saying, let me, for clarity, also just add, where is the...
So are we looking at a library right now?
No, this is this was an example that I took, and this is a new sketch I just created. Okay, it's not longer than this thing here.
But you're calling you're calling functions from the example?
No, this thing here. So there's have to be an include. Hang on, let me just see if I can find that. SD time here. Let's take this one. So we have to include these lines here. Okay. Oops. So this is a library. Okay.
Mm-hmm.
So you define these pins like I did before, and then you so you set the pins up, and then you do a SDMMC begin, and then you you can figure out what card type and things like that. I'll do this thing here just to make sure there's a card plugged in, and that is actually it. Here's like some pin definition. I'm just gonna include it for the purpose of making this thing here complete. So obviously it's not necessarily the right pins, but you get what I'm talking about here. Okay. So this is the pins, so they're defined, and then it have this. There's something here called 1-bit mode, but you don't have to focus about that. Let's just see here's a setup. This thing here goes to Wi-Fi to just to find the time. Okay, so we do all this, it's fine. And then, there's SD card begin. So I have that here. And you can just use it like you have it there. And this is actually the code. So if I configure these pins correctly, then this should work.
Okay. So you're actually putting the append in your loop so that you could also hypothetically put your X-chip sensor reads in the loop itself.
So I can show you the real code, but I'm probably gonna.
I think it'd be better just to upload it for everybody rather than we're in the weeds here. But if you could upload a code that actually reads X-chips and writes to the SD cards anywhere. It would. We're doing a lot of workarounds to do this, and it would help to see the right way to do this.
Okay, I will show you that. Let me just open
don't think you need to show us.
this-
You can just upload
Okay.
it to the GitHub or to the Canvas
fine.
or anywhere.
That's good. That's good. I'll make a
So-
program that you can just run.
Okay, then the last question was, you mentioned if we're running over USB-C, then we have to enable something mysterious in order to actually see anything on the serial monitor.
Yeah, let me show you that. Share. Okay, so if I take, I'm in Arduino now, and I'm sharing my screen, and if I say example, for example, under communication, there's something here that called ASCII table. It just prints out an ASCII table. So, so here's my ASCII table here. I just changed the speed, 115 to 200. And what this thing here is that it's simply just a lot of print statements here, nothing special. And I have my thing plugged in, and there's nothing connected right now. And if I say tools, you can see here that when it comes up with this odd thing here, it's actually because it's in this bootloader mode. So I'm just doing this little reset play here. Okay. So if I go here, then I have now the right port. Okay. If I say if this has to be enabled in order for me to see anything on a serial monitor.
Got it. So it's
if
just the tools menu drop down.
Yeah, it's in the tool drop. Sorry, it's underneath where you set the ports. It's the top one there.
Got it.
And the important part is that if you plug it into the USB into the PPU, then and you have this CDC on, it will still send the data out to the USB, and then of course you don't see it. So this is normally false or disabled. Sorry, this is normally disabled when you set it up. And then the data comes to this one. But if you want them to come this way here, you have to enable it. So if I program this thing here, let's see if this example works. It's a little odd, but it writes something out to the screen. So that's the important thing for me. So I have already, opened the serial monitor here. Yep. I always do that first because if the compilation is successful, I'll just jump straight into the serial monitor, and you should be able to see something. But you have to set that to enable as in the functions at the top function in the tools menu to see anything on the serial monitor. So this thing here is uploading. So give it like a couple of seconds. And then because I put it into download mode, I have to now press reset manually. So I do that, and you can see it writes out this ASCII table here.
And if we disable that and connect it through the PPU, we'd still be able to see over serial monitor.
Yeah, so I can demonstrate that because
the CWA says the CWA GitHub says in order to run over the PPU, it needs to be an upgraded PPU or a latest and greatest. Is that shipped to us yet, or to the?
No, it's not released. So the thing is that this thing here is the latest, greatest, as you call it. They look very much the same. So this one is the old one. The new one have these two transistors. There's also like a version number down in the corner here that will tell there's a difference. We haven't released this one yet because you can program it over the USB. And I strongly suggest you program it over USB.
Okay.
The reason why we haven't released it is because we have done this slight modification on this one to this one, but we're adding another modification on this thing here. We're adding a power bank keeping alive. So the problem is that these circuits use so little power, so if you plug it into a power bank, they normally just turn off. So this version here will also have a power bank keep alive function, where it just triggers the power bank not to switch off. So that's coming in this one here, also getting released. But if you just want to see the results, if you take this one here, and I'm not want to program it, but just want to
Monitor the serial monitor.
Monitor, okay? So if I take this off here, and now, of course, on the screen, you can see it says disconnected. I plug this in, and then I have this one here. It's still disconnected here, okay? There's no connection. Even if I go up and select this other serial port and go here, nothing comes out, okay? So I actually have to go in here and say disabled, and I have to program it like disabled. Even if I now go in and open the port, nothing comes out here. So if I want to use this thing here, I have to program it with disabled up here, and then I can see the result on this if I for some reason want to do it this way. Does that make sense, Mike?
Yep.
Yeah,
okay. I think we should let Judy take over. Thank you.
Okay. You're welcome.
Are
Judy,
there
you're
any
good.
other questions? Are there any other questions?
We have a few, but we are very new at all of this. So a lot of the academic lingo, we're not catching most of it. I know most of our kids are not. We just had the basic question. They were asking a lot of questions while you were talking. Basic question, if we do just the base upload code on a sensor, and we plug in a sensor, stick in an SD card, is it going to automatically write to it or not?
Yes, it's automatically going to write to the SD card.
Okay. And then we can take that SD card and transfer that over into the computer system that you just showed us to get the data.
You can, the SD card, the data on SD card comes on what's called a comma separated file that you can open in any spreadsheet.
Okay, perfect. I got it. I'll help them as well. But that was my main question. And the processes that y'all are talking through, is that in the Canva course where we can refer to it as we're getting started and moving into the next step?
Recording in progress.
I haven't I haven't put that into the Canvas course. I'm probably gonna have to edit this video and put that in. Yeah. Yeah, okay. I'm gonna need to speak to Bjarke about how we're gonna do that. Yeah, for you to be able to get to your next steps. Okay.
Great. Perfect. Thank you.
Okay, great.
Somehow you managed to ask the exact right question despite us getting totally lost down the road in more advanced stuff. So don't worry, you're at the exact right level and question, and we'll work on bridges to get everybody to writing their own programs and stuff.
Okay. Also, Bjarke, do you think it would be possible if, if not everybody needs to maybe write their own, if we can have some example?
Well,
I'm
going to make...
Yeah.
I'm going to make a very light example where I read like 2 sentences and write to the SD cards and nothing else, not writing to a screen or anything like that. Just super, super simple. And then I'm going to upload that to GitHub so people can see that. And that, with that example, you should be able to read any kind of sensors and write the data to the SD card. So I'm going to make an example like that, and I'm going to document it very well so people can see why it's doing certain things in the code and why I do certain things. The important part with writing to SD card, and might as well just say it now, so when the code comes out, is that what I normally do is 1 or 2 things. So one of the things one has to understand with these the bigger computer system, even these small ones, is that when you open a file and write to it, it doesn't write to the SD card immediately. It only writes to the SD card when the buffer is full, or when you say close. So if there's a power failure in the middle, then it doesn't read the rest, write the rest to it. So what I normally do, because it's fairly quickly and I only write a sentence here or there, is that I open the file, then I write my records to the file, and then I close the file. And I do all that in a loop. Okay. So I'm just saying that because that's in order to make sure the buffer is emptied and written out there. The other thing I do when I just do my own program is that I just open the file I have and I write to the bottom. What one could do is could go in and say, well, I want to write to a new file. So I'm going to try to find a new file that works. But I'm not going to go into that. I'm simply just writing to the bottom of the existing file. And that's the reason why I use a pinned file and not write file. If it doesn't exist, it will create it and it'll just write to the end of it. So when you start playing with that and your code doesn't really work, remember to delete your file from time to time so you can see the new code you have written to it.
Bjarke, this example code with just reading 1 or 2 X chips and writing to the SD card, I can tell you we've been desperate for this little example code for a while. So I can tell that everybody else will be eager for it soon. And like we did it, we just made our own, but it's real ugly and we did dumb workarounds. So I can tell you that will really shortcut all the other groups.
That's fine. That will come out the next 2 days. I promise you that.
Great.
Thank you so much.
Bjarke, yeah, that would be great, because what I would really like is the focus to be on which sensors are going to be used and more on the science and the experiment than getting caught up in everybody trying to write their own code. Maybe it's because I'm not a developer at all. For me, I don't believe that we should be reinventing the wheel across all the groups in the project. I think it would be a lot more interesting if we only have to invent that once, and then everybody can do different science, and then share their data with everybody after the fact. I think let's focus on, if we could focus more on the science of the experiments. I think that would be great. Okay, any other questions? Amanda, you okay there? Susan, hi. Sorry, Susan, I didn't greet you earlier.
I just have one thing I want to add.
Yes, of course.
So this thing here, Mike, you might like it, but there might be others that want to do a lighter version of prototyping. So what we have done is that we have done this little board here. It's a quick connect board, and that allows to take sensors from SparkFun or Adafruit that runs Quick Connect or STEMMA. They have different names for it. So you can take like this board here. So this is an example from Adafruit, this one here. And there's a connector here in the one side and the other side. I didn't have the cable, so I just put it in. But what you would do is you would take one of the cables that typically comes with it, click it in here, and then click it in there in one of the ports underneath. You can see that's how it looks like underneath. And then you have actually included this in here. Of course, you have to, the libraries are going to be, from the Adafruit or SparkFun. But if you do anything that's a little special, then you can easily do it this way here. This thing here will definitely require soldering. I just want to say we have that option also, if anybody want to play with other sensors than the one we have available.
Okay. So yeah, those perf boards are going to be coming to everybody next in your next shipment, and hopefully in the next few days we're also going to receive the extended cores for our rideshare. So you'll also be able to get those soon as well, so you can start working with those. Let me take us now to the timelines. So this is where we're sitting at the moment. So what we're doing is we're busy with workshop 1 right now, understanding all the sensors available, payload design, fundamentals, etc. And so when we do workshop 2, which is either on December 3rd and then repeated on December 4th, what we're going to be doing here is we're going to be preparing for the high altitude balloon launch, what is required and which deadlines need to be met. And what we need to start doing after that is developing the code for that extended core so that you can make absolutely sure that you are writing data to the SD card on that extended core, and that each time it gets powered up or power cycled, that you're not overwriting those files. And what we're looking at is around about mid-December. If you are wanting to participate in the high altitude balloon project, then you probably need to be ready to ship your extended core with the sensors that you want to put onto the high altitude balloon around about mid-December. It's a nice to have. It's not a must have. It's a really interesting experiment and project to do. So these timelines come straight out of our shared Google Sheet. Those timelines and that schedule on that sheet is the one that's being updated constantly. So that is where you need to go to do that. And that is it from me. And I'd just like to know, we have run a little bit over, but anybody else with any questions or comments or anything else?
Oh,
Good.
sorry. I missed half the meeting. Where do we find the recordings for the meetings?
Susan, what I do is that I combine the recordings of both, whichever is more suitable. And then in the Canvas course, there is a page that has all of the workshops. And then as we upload the different workshops to YouTube, you'll find the link there.
Okay, great. Thank you so much.
Yeah, and then what I usually do as well, and I can certainly do it this time, is I do an announcement to say the video is ready.
Okay.
Go and have a
All
look
right.
at.
All right. Thank you.
Absolutely. We do have a MaxIQ Space YouTube channel. So every time we upload a video there, it'll send you a mail or something like that, an alert to say there's a new video that's been uploaded. So you don't necessarily need to go to look for it. Good, great. I think we've lost Mike in the snow in Montana. Mike Wallach. Great. Amanda, are you okay? Everything good your side?
Yes, we are doing great. The students are having a debate tomorrow. They're all presenting the different design experiments that they each individually prefer. And they're going to be presenting and defending their stance. And then they're going to have a democratic vote. And that'll help us kind of determine the direction we want to head to. But they're really enjoying. They like talking and debating and arguing. So this is them do it in a very healthy way. So
that's fantastic. Excellent.
It's very popular these days.
Yeah. And Gerrit, how are you doing progressing towards your experiment?
All good. We're still discussing with our team, deciding on our experiment, but we're working on that.
Perfect. Excellent. Excellent. And Susan, how's it going with you and your team?
Oh, it's going well. We're still early in the discussion phase. I got to implement more of the Canvas into our curriculum, but everything's going according to schedule. Thank you. I'm attending that workshop next week with James Gorman.
Fantastic. Great. Good. Then we're going to get to meet in person. That's going to be wonderful. Terrific. Excellent. Mike Galvin, anything else from you? Are you okay?
We're doing good. Our students are trying to do like we're prepping some basic X-chip payloads for the balloon launch, and then some of our teams are trying to get ahead of some more like custom stuff for the ISS launch. They're taking too long because I want to save some time to actually do some vibration tests here and thermal tests. And so we're actually trying to finish the experiments, finish design build as fast as possible so we can do some actual launch qualification, teaching launch qualification and launch testing and stuff like that. But good progress, interesting experiments, and everybody seems to be making progress. Perfect.
Good. Excellent, Mike. Thank you so much. And yeah, I think Mike Wallach probably needed to leave the room. Bjarke, any closing words from you?
Good luck, everybody.
Great. So on the Discord server, if you want to be admitted to that ISS group, just let me know in the general chats, and then I can certainly make sure that happens. And yeah, any questions you have, if you don't have access to Discord, then please put it on the canvas under the discussions. And yeah, otherwise pop me an email. And great. So if we don't see you between now and then, our next workshop is going to be first week of December. And good. So thanks, everyone. Have a wonderful rest of your day. And for those of us in Central African time night, it's after 10 p.m. here. So we're going to head off. I'm sure it's the same for you. Okay, great. Thanks, everyone. Cheers.
Thanks. See you. Cheers.
Thanks, guys.
Thanks.